Hello class, today I'm going to show you how we can simulate fluid passing and flowing over a cylinder. Right. Let's start our workbench. Okay, workbench is open. Because we are going to deal with fluid flow, I'm going to use fluent ANSYS this time. Double click over fluent and let's write the name flow over cylinder. Okay, open geometry. Okay, our space claim is ready. Let's select one of the surfaces for drawing. You may say, why this type of flow? Let me show you something before starting our simulation. As you can see, we could have many occasions of having like different shapes in front of a flow. It could be a triangle shape like this, which can create some vortices, or for example this high-rising building, the clouds are passing through and you can see clearly the flow pattern here, left and right side of this high-rising building. For this case, it is clear the Reynolds number is very small, but if it was larger, we could have different shapes. Or in the nature, you can see, for example, this is something like a mountain, and when clouds are passing because of the wind, we can see there are some vortices after this blocking mountain. So I'm going to simulate something like this. As a blocking object, it is going to be cylinder, and flow is going to pass through this object, and if Reynolds number or the velocity of that flow was high enough, we may see these vortices after left and right side after this object. Okay, now let's go back to our simulation. So I'm going to change the units to meter, so it will be easier for me to draw like a large 10-50 meters geometry. So what is my plan? Let me tell you the plan. Instead of drawing solids, I'm going to draw fluid domain. So first, because I'm drawing fluid domain, I'm going to draw a large rectangle and create a hole inside it to simulate. And I'm going to go to simulate 2D case because we know that we have a limitation of the mesh numbers. Instead of doing 3D simulation, which is very time consuming and it needs a lot of mesh, I'm going to draw 2D cases. And you know, if it is possible to simulate 2D case, it's better to use 2D. So let's do this. So 30 meters here and 50 meters for this side. Now I'm going to draw a circle at the center and delete that circle as a cylinder. So let's draw it. I want to know where I'm drawing from to find the center, so I select Cartesian dimension, select the origin, and for that part, because I want to be in center, it is going to be 15. Click tab key to move the other one, negative 7.5, because the total distance was 15. So I found the center, and the diameter I'm selecting is 1 meter diameter. I have a reason for that. Later I'm going to tell you. So this is my fluid domain, and this circle is going to be our cylindrical object, which is going to block our flow from the left side to right side. Okay, so let's select all the curves and click fill to fill the region. Now it's ready. But as you can see, this is not a hole. It is filled with the materials. So we need to split body. I'm going to first select the object we want to have. The second one is cutter. The cutter is going to be this line. And the third one is asking for region we want to remove. So I want that piece to be removed. So done. Click Z button to fit in all your drawing here. So this is my fluid region domain, and this hole is going to work as a cylindrical object. So basically we cut this building and fluid domain, and we are watching from top. Okay, enough. Let's go back to workbench. Oh, I accidentally opened two workbench, so let's go back. The second part is mesh. You need to take care of mesh part, because when you're simulating flow, you need to know that mesh quality is really important. If your mesh is very coarse, you are going to miss some of the behavior fluid may have. So you need to have fine enough mesh to see all the details of fluid flow. Okay, let's see the surface information. The thickness is 0, which is excellent because I'm looking for 2D case. First, let's see what type of mesh is going to generate for me. Awful. Let's add method. Because it's 2D, I can go for triangle. So triangles. Let's see if it improved or not. Yeah, why not? It's better than the first case. For sizing, I'm going to select the geometry, apply, and let's go with 0.2. Much better. I also want to have more details close to this cylinder, so let's select this one and insert sizing. Instead of giving size, I'm going to give the number. I want to have 80, for example, there. So if I zoom in, we are going to have 80 divisions there. Let's see if it's improving or just no effect. Okay, much better. As you can see, we have better quality there. Let's see what else we have. I can change the size function to approximately and curvature. What else? Oh, I want inflation. I can increase inflation, for example, to 50 layers with 2.5 growth rate. Let's see. Where is inflation? If I increase it to 80 and change this to 2, let's see what is the effect. So it didn't affect that much because we are the others cover. So I'm going to change this to 1.8. meter. Okay, I'm happy. Yeah, it's good enough. If it wasn't good, we need to go back and change this one, improve the mesh quality, and do the simulation again. So let's update mesh here. Sometimes it takes a few minutes to update. Let's open setup. For setup, I'm looking for double precision. Instead of using serial processing, I'm going to use parallel because I'm aware that my computer has at least 7 cores. Let's ask ANSYS to use at least Fluent to use at least 4 cores. I also have 1 GPU. So let's take advantage of those facilities. Okay, now you are in setup domain of Fluent. On the left side, all the options you need to check and change will be available. If you double click, the task page is going to change based on the option you selected in the setup part. Okay, so for example, if I double click over general, the task page is going to show me the general part or options. So the first one is asking what type of solver I want to have. For fluid calculation, usually we have 2 options, pressure based and density based. It's details about the formulas. Let's select pressure. Velocity is absolute. It's not that much important. 2D space is a planar. If you had asymmetrical cases or asymmetric swirl case, you can select those 2. For this case, I want to have transient behavior captured. I could have steady state, which would be much faster, but I want to have some videos to show the behavior of the flow when passes through this left side and right side of this cylinder. So let's select transient. I could add gravity, but for this case gravity doesn't make sense, so I'm not adding gravity. The second part is going to be models. As you can see here, we have a lot of models: multi-phase, energy, viscose, radiation exchanges, and many other parts. Multi-phase, when you have 2 different phases, for example air and water, you could use that one. Here I simplified this question in a way to have just fluid domain, so I don't have 2 phases. Energy, when we have temperature change or the effect of temperature, you can turn on this. For viscose, if I double click, you can see different options we have. Inviscid, laminar, and the others are turbulent models. If you want to know more details about all of these cases, you need to Google it. But for this case, I'm going to use laminar flow. And yeah, so this is a default version. Let's check the materials. ANSYS usually asks us for two types, fluid and solid. Here I just have fluid, so let's create a fluid or select a fluid. Double click. You can use from Fluent database. As you can see, I clicked it here. I can select whatever I want. For example, here it's a liquid water, vapor, other chemicals, many others. And if I select, for example, water, I can easily just click copy and click close to get that one. But I don't want to do that, and I'm going to create my own fluid. I'm naming my fluid, and density for that fluid is going to be 1, and viscosity is going to be 1. Why I did this? Because if you remember the formula for Reynolds number, it is density times velocity times diameter divided by viscosity. So I selected this density and viscosity 1, and diameter is already 1 meter, so velocity is going to show me the Reynolds number. Why I'm doing that? Later we can see the result. So create and change, yes, and close. So I created my fluid here. And regarding solid, we don't care because we don't have any solid here. The next part, let me close this part. The next part is going to Zelson condition. Let me open, double click here. And the surface I have, which is this green meshed area, supposed to be a material which is my fluid. Sometimes when we have like several different fluids for several different parts, you need to make sure the one you want is selected here. Sometimes as a default, ANSYS or Fluent selects the first one. Okay, we are happy with this one. Let's go for boundary. I didn't include any part for boundary, so I made a mistake here. Let's close this. Go back to the mesh. Okay, now the mesh area is open. I need to name some parts. For example, the left side is going to be my inlet. So I click the left side, right click, create a name selection. So and I'm going to name it inlet. For the right side, let's click it, right click, create a name. This is going to be our outlet. For the bottom side and top side, so control click, both of them are going to be called walls. And this one is going to be called cylinder. So I created some names here for different sections. For example, inlet, outlet, walls, cylinder. So by creating these names, later when I'm applying the setup, I can say, okay, show me the inlet and give this velocity for inlet, or for wall this specific properties for those parts. So let me update the mesh. I'm opening setup, same options I already selected, so ANSYS knows that. Okay, let me check if this is okay. Model is okay, material is okay, cell zone is okay. Now I'm opening boundary condition. As you can see, we have those names here. Now I can specify, for example, for inlet, double click over inlet. I want to have 90 meter per second velocity of my inlet from left side. Great. For outlet, automatically selected pressured outlet, which I like it, and I want to this pressure outlet, which means whatever pressure is at the cell before this line, just copy for the other side. So it is going to be constant after that, which we want. For the wall, ANSYS already has a wall option, and we like that one. We are going to use it. So it is going to have no slip condition and stationary wall. So we want that one. What about cylinder? Again, it's wall, so no slip condition and stationary wall, which is very good. Let's open reference values. For reference values, I'm going to ask ANSYS to select values from inlet. So because inlet is going to starting for the new information, or the velocity or anything is coming from inlet, so it's better for ANSYS to start getting information from that side. Let's go for the solution part. Method. For method, we have several schemes: simple E, simple C, piezo, coupled. They have some advantage to each other, but for this case I'm going to use just simple, and you are already familiar with first order and second order, which one is better. So here they are second order, and here for the transient formula, which is time gradient, it's first order implicit. I'm going to select second order implicit, and you know implicit is better, and when I'm selecting second order, it will be much better. Yeah, done with that one. Control. These are the relaxation factors, basically showing it's these coefficients. You multiply your pressure, your density, your body force, your momentum with these numbers to gradually grow and give your code a chance to converge. They are helpful thing, but let's use as a default. Initialization. For initialization helps us to give initial numbers for the mesh we have here, because ANSYS needs some starting point number. So we have two different initialization. Let's select hybrid initialization and click initialize to solve. Basically, ANSYS is going to put some numbers from the reference values inside the FEM formulas or ANSYS finite volume formulas to create some numbers for each mesh, which is kind of a starting point. Calculation activities. I want to save, auto-save every one time step, so I want to have that. What else? Let's go for run and calculation. Time step, I'm selecting 0.01 second for time step, and let's repeat it 300 times. And the maximum iteration, I'm asking, for example, for 50. What is this maximum iteration? For each time step, ANSYS is going to repeat calculation till reaching a minimum acceptable error. For example, 10 power 3, 10 power 4, 10 power 6. If it didn't reach that minimum error, it's going to continue. Using this maximum iteration, you say up to 50 iteration. If you reached, you reached. If you didn't reach that criteria, just leave it and go for the next one. Don't stay there till reaching that specific value. Okay, let me check what else we want. Nothing. Yeah. Okay, let's calculate. It is going to take some time, maybe 30 minutes or less. I'm going to pause my recording and come back when the solution finalized. Okay, calculation finished, and as you can see the information, calculation completed. Let's click OK, go back to the workbench and open result. Okay, this is our result. For starting point, I'm going to create a counter. As you can see, the icon is similar to counter. So let's click, accept the name. Domain is going to be the surface we have, location. We have inlet, outlet, cylinder. These are the names we selected. We don't want to have. We want to have our contour to cover whole area here. So we have symmetry 1 and symmetry 2. I'm going to select symmetry 1. Also, I'm looking for velocity, and the number of contour 20 would be good. Let's see. Now you can see, yeah, the velocity is high enough, which is going to be 90. Reynolds number was 90 because velocity was 90 meters per second, and I selected density and viscosity to be 1, so Reynolds number is going to be 90. For this flow, we have a name. We call it one Karman flow. If it's above 80, Reynolds number is above 80, we are going to have this type of flow, which is going to have some vortices left and right side all the time. It's like a vibration after this blocking object. So as you can see, this is for 20 contours. If you want to increase the quality, you can increase the number of contours to 200 and apply it. Now you can see this picture would be much more better and the quality is better. Still, you can see some non-uniform dots, which is because of the quality of mesh. I could improve the quality of mesh after cylinder here, which could be much better for our results. But Yeah, this is just for as a showcase, and it's for presentation. Okay, this one was for velocity. Let's go and check pressure. Yes, so high pressure at the stagnation point here, which flow comes and hits here, we have high pressure, and lower pressure left side and upside and bottom of this cylinder. Okay, let's see what else we have. Remember, I asked Fluent to save every time step, so I should have at least 30 time step and information for 30 time step. So let's see other information for other time step. 200 is a lot. Let's go back to 220. It will be faster. So I'm going to click this button, time step selector, and see which this picture is for which time step. As you can see, this is for latest time step, which is 300. So if you want to know what happens at time step 200, you need to select that one and apply it. Or for others, for example, number 100, it is going to be like this. Okay, let's see another option, streamline. I'm going to click streamline, accept the name, and wait for streamline. Okay, here. So it is going to be again surface. Start from inlet. So the lines are going to start from inlet. Equal space 25. I'm happy. Yeah, let's apply and see it. Where is it? You can see streamlines because our counter is already on. I'm going to turn off counter. Now you can see our streamlines. And this streamline, as you can see, is the stagnation point streamline, which is reached to this point and it's 0. All of a sudden, the object stops it, and you can see flow upside and downside of this cylinder. Again, same thing, you can change the time step results and apply it, and you can see here we have some flow fluctuations after cylinder. Let's turn off streamline and turn on counter. This time I'm going to generate a video. So animation, click the animation, and I want to create animation for time steps, and I would like to save that one. It is going to be saved on documents. You can change the target address, and for the format, yeah, I'm happy with Windows Media video file. Now let's click play the animation, and it is going to create our animation. It starts gradually, and you can see velocity at the top and bottom is higher, and then we have a 0 velocity at the behind the cylinder. Let's see, and for stagnation point, again it's blue, so it's velocity 0. It's a nice presentation of that. And now it starts to fluctuating. Let's wait for it. First it's slower, and then gradually should create some vortices, and those vortices are going to separate. Okay, the video creation step finished. Let's check documents, and as you can see, it is created here. Let me open the video and watch it. Thank you very much.